Hello everyone. Today I'll present you our library on the dialog systems. So this is the project, iPablo project, which is solely devoted to creation of such library which should take to ease the creation of dialog system, which is not that easy. So let's start with the motivation. Why we actually do need this library? Because as you can see, a few years back already, the total audience of the most popular IM systems, the most popular messengers, is already bigger than the audience of the social networks, and whereas the people, there is the money. So we need to follow the people, and people are going to have dialogues with each other. This is the way to work with people, and this is how we actually want, where we actually want to be. This is a little bit scary picture, I could understand, but this is, you have no need to get like exact each logo on this picture. This is only for you to get the landscape. There are a lot of vendors, a lot of some chatbot companies in the United States, obviously. In Russia, there are much less companies who are doing the chatbots, and the market is like ready for you. You could start with that, and you could apply our library, hopefully. So let's go next. This is, I think, the main picture I have today. This is the dialog system itself. It consists of four main parts. I'm not mistaken. The fourth part of the dialog system is a user, person who actually talks to a bot, to a system, and there are three development parts, like natural language understanding, which is understand the language, understand what the user wants to say, which is the intent. I'll talk more about it later. What is the other stuff we could extract from the utterance of user? Okay. After that, we have extracted all the information we want, and we're going to manage the dialogue. We're going to have some policy, have some decision on how to reply to a user. And the last but not least module is natural language generation, which is mostly in production, has been done by templates or some kind of retrieval. Like if you, I think everyone in this room have heard of Yandex Alisa. They are using really good retrieval models on the dialogues, and by that they actually have smooth dialogues. But still it is not the generation, and generation is, I would say, scarce in production. I actually knew maybe one or two examples of that. It is not common because it's dangerous in a way. Okay, so I was saying that there are four actually main parts of dialog system, but I was wrong. Not wrong, I was trying to get this out of scope, and now it's time to talk about the next thing that we have, the semantic frame representation. Semantic frame, this is the thing which is core thing for the dialog system as we know it. Dialog system which is goal-oriented. I would say yes. I would say that there are two kinds of dialog systems. There are chit-chat systems which are going to just talk to a person and entertain his or her, him, her. The other type, which is more production type, the goal-oriented system. Goal-oriented system is solving some goals, so solving some task to which a user want to complete. Like in the examples of my colleague, this was the ticket reservation, or that was something other. In my slide, this is restaurant reservation, and what is we going to have here? This is the ontology. The semantic frame is ontology. Are there people who haven't heard about ontologies here? Here, I mean, yeah, I don't know, maybe. I'm just asking. If everybody knows, that's really nice, because that was a surprise for me that not everybody knows about ontologies, but still. To create an ontology of the domain, we always work in some domain. Here is the restaurants. We need to analyze the domain. We need to analyze the already existing dialects, or we need, I don't know, have some understanding of the field, so we could have some experts in help. So we're going to create the ontology with where we're defining the special values. Like for a restaurant, there are here only three main features, like type of food, the location, and the price range for the restaurant. So this is the knowledge we bring from outside. We're not learning it, we're bringing it. And one of the actual challenges, as far as I know, in the field is automatic creation of ontologies. I don't know big advances in that direction. Okay, so I think that is pretty obvious what is going on. Like a person asking us to find a restaurant which is cheap, Taiwanese, and in Auckland. I think this is not a good choice, but still. Okay. I was saying that there are some features, but these features, we call it values. Slots, not values, slots. And these slots could have values. And as you can see here, there could be some values to these slots. What I mean by slots? I mean that in the beginning of the conversation we have empty semantic frame with no data in it. We need to understand what user is going to say, what user is saying us. And for that we're using so-called named entity recognition. So we try to understand what is what in the utterance. And here we could see some interesting point here. The interesting point is that center of town is interpreted here like center, just center. So we have user input, which was hopefully recognized by named entity recognition, and we need some slot filling process, which is process the input, the recognition input, and which output us the field slot. In our system, by default, of course, you could change everything. Our library is open source, and you could just contribute, or you could not contribute if you do not want to. We are just using some simple search, fuzzy search with Levenshtein for this for such stuff. So this is the named entity recognition here. The next part of natural language understanding is intent classification. Intent classification, this could be two types actually. The intent, like there is intent classification and there is domain classification. We're first of all we're defining the domain in which we are working. That could be like movies, restaurants, sport, or whatever you want it to be. And after that, inside the domain, you're trying to understand what's user want to say. Like user want to say some information to you, or he or she could just want to know some information from you, not giving it to you. And there is another intent classification which is inside the domain. Okay, the third part, this is dialog management. I think I need a little bit of explanation here. Like we have the observations, the number of observations of user behavior, or like occurrences from user. We have states for a system. Like once system received an occurrence, it changed its state to some point where it's giving some decision, some action. So the first is the observation changing in state, and the action. Action is then sent in a way sent to user, and after that we have been given by another observation. This whole setup it could resemble you of some maybe reinforcement learning, and this is not by accident. There are a lot of advances in this direction, but still I would say in production mostly it's rule-based systems, and we're providing a rule-based baseline for our chatbot. Actually, not only rule-based, but also the neural network-based. You could check. I'll have a few slides about that. Okay. The next thing that we need to understand, this is the dialog state tracking. This is really a tricky part, because there is a problem. We have some recognition. When I was saying that we have named entity recognition, I haven't said that named entity recognition is not perfect. I think it is obvious, but we need to understand that it is always not perfect, and we always could have some chance of mistake. And the problem is, like, if you have not only named entity recognition, but your utterance has been recognized from the speech, there definitely will be some errors. I like could have bet on that. And the problem here is described like that. Person asking us about Thai restaurant, and the system haven't understand that. Is it Thai or Turkish? It's maybe not that. Maybe now it's obvious, but in some noisy environment it could be not obvious. Still, it's just example. And here we have like here we have understanding the food. This is Thai, and Thai is not that really confident. And after that, we asked about Thai or Turkish. The representation of the utterance is like the most probable is hello, like hi. The next is Turkish, and the other is Thai. And since we have prior on Thai, we have the most probable option Thai. This is the problem of state tracking. If you have, this is like the solution of dialog state tracking. So if you have some previous history, you always better could recognize what your user is talking to you. Okay, The closing part of the dialog system is template-based generator. This is just number of templates, and maybe there is only one template for each action which has been provided to this module by the dialog state tracking, but still it could be like hundreds of options, and you need to score them to understand which is like speech style or something like that. And you need to fill the values. So there are some slots in the output, and you need to fill it with some values from database or which you have memorized. And this is actually a bit of a problem because still in Yandex Alisa, which is great, there are some issues, like Alisa has never remember how you call yourself. Like my name is Valentin, and she forgets it the second it's gathered. It's obvious for a person who actually developing dialog systems why it's so, but it's not obvious once we're trying to create the natural interface, dialog interface. Okay, this is that was a part about the like theory. This is the part about what we actually got here up to date. This is FAQ skill for Russian and English with a tutorial. Like what is that? This is just we classify the input of the input utterance, which we interpret like a question about some FAQ knowledge base, and we're actually answering with the answer for this question. Interesting part that we have Elmo, and we released Elmo for Russian language. I think we were the first who done this, and we included Elmo source code into the library, so you could train it with the library if you want to. Also, we have goal-oriented chatbot, which is a whole chatbot, which is already built, but it's built on a really restricted corpus of restaurant reservation. This is the corpus of dialog state tracking challenge 2. What is also important, there should be some ODQA here somewhere. Here, ODQA. We have ODQA skill, which is open domain question answering. Like you have an open domain question from a person, you answering with some sentence or phrase from Wikipedia, for example. And this is surprisingly popular module from our library. I haven't realized that people need it so much, but still, for some reason they do. This is seventh beta release of our library. There should be 8 already, and there are some other stuff which we could use. If you haven't remember, if you forget about the name entity recognition, this is a refresher. How you could use our name entity recognition? Name entity recognition, you could just train it with simple string, like train the train with the config. You could interact it in the command line, and this is easy. Like you just give it some sentence, and it gives you back the text for it. And this is what we actually, why we actually proud of our name entity recognition. It's the best for Russian language. We have providing the pre-trained name entity recognition model for Russian. I don't remember if I do for English, but still it could be trained easily. This has been published, I think, last year here. For intent classification, as I said, there are two tasks, intent and domain classification, but still the architecture is the same. So we could work with the same architectures. We have a variety of architectures which has been tested on some Kaggle competitions, and you could use any of that. This is maybe the best in our experience, but you are not restricted in usage of this model. You could use any architecture and write yourself any architecture you want, actually. Okay, this is the architecture of the dialog system. This is the examples of our goal-oriented bot is working. It could be working. It could demonstrate some intelligence in big quotes. How you could get it? You just train named entity recognition model for it. It's really needed really hard. You could train intent classifier, which makes it better, but still it could work without it, just based on rules. And just after that, since you have trained the other modules, you could train the goal-oriented bot, and you could interact with it in command line, or interact with it in Telegram. Telegram is the best. This is simplest integration, but we are now finishing the integration of Microsoft Bot Framework, so we'll be able to interact with people in other IM systems like Skype or I don't remember all of them, but the Skype is definitely there. And we have pre-trained goal-oriented bot for Dialog State Tracking Challenge 2, as I said. You could have it. It could be easily downloaded. All of that is on our website. Like we have this Deep Owl of AI. This is the site of our library with whole documentation, if you want to. This is a demo of some of the skills we have in our library. Let me check how much time do I have. I still have time, so I could have it here. Like this is the installation. We have pip installation, so you just pip install deepawlof, and I think from this release it could be working on Windows, but still this is a bit beta. Be careful if you have any issues with Windows or any other issues. You just go to our GitHub and write an issue. We'll try to close it as fast as possible. So also, if you have some code to contribute, we also will be glad to have it. Okay, this is about use cases. The use cases we are thinking where our library could be helpful, but still this is not the obligation. This is just like guideline, not the only way to use it. Like we have incoming message routing. We analyze the topic of incoming message. We route into a specialist, and the specialist is answering for this. This is the simplest case of usage. There are more advanced cases, like this is retrieval of relevant answers. Like we have topic analysis. We have some available answers from somewhere, I would say about that. And we scored them by relevance, which is actually has been the same skill that as ODQA, which I have mentioned before. We suggest this to the operator, and the operator answers the question, actually. There are two more cases, like answers from some FAQ, maybe knowledge base analysis. As I said, some available scoring answer. Available scoring, like we have already have a set of predefined answers here, and we have answering if only system is highly confident, and giving back to a person if it's not. Okay, and the last guideline is like we're analyzing the utterance, we search documents and trying to retrieve an answer from there. This is the actual ODQA use case, and answer if it's highly confident, and that's it. Okay, there are questions. I think if I have time, I could give some more information, or I could go to directly to the questions. If how? Okay, so we have this question answering system. I was talking about the ODQA. How it's actually is going to work. We have some knowledge base, like FAQ, or maybe external knowledge base, maybe database. We actually have in previous release the database integration module. So we're rank the document by some retrieval method. That could be some classic methods, like we are using Elasticsearch, which is, I think, state-of-the-art in this field in open source. And after that, we could use answer generation, which could be dangerous, and we could use answer retrieval, which is considered to be safe, at least much more safer. How it's actually the problem statement. This is the example from Squad dataset, Stanford question answering dataset. This is the context, the paragraph from Wikipedia, the question to this paragraph, and in the bold is the answer to the question. So the answer is this three words, maybe with some surrounding words to give a person a context. Okay. What is the datasets? The datasets is, as I said, Squad. The context from Wikipedia, 23,000 questions. 23,000 contexts, 100,000 questions for English. Other stuff is SDSJ, Sberbank Data Science Journey, Task B for the previous year, which is 80,000 questions with context from Wikipedia and other sources, and this is the Russian language. So there is an option of the Russian language open domain question answering also. I think this dataset will be is not released in full, like it is released partially, and we use the open part of it. Okay, how we could use it? Again, you just go to the training. You just train the using the config. You could interact using the config also. And another option, I haven't said it before. We have a seamless integration to raise an API. So there is a REST API that could be raised by one command for I think almost any of the models for Squad is like here. Okay, so this is the finish of my talk. I will be happy to answer your questions.
choice. So yeah.
Okay, of course.
I have a simple question. So, folks from JustAI built their own domain-specific language that allows people to build conversational new experiences for different kinds of chatbots and AI assistants. And at the same time, you guys have tremendous experience in developing identity recognition technologies. So I wondered why you deep dive into the conversational AI on your own instead of trying to collaborate together by bringing the best pieces of both companies.
Both companies. I don't get the company, but actually I don't know much about JustAI. Unfortunately, I haven't yet have a conversation with them. But I could answer you in general, because not only JustAI is doing the DSL language on that, the Google Dialogflow, Yandex Alisa also is have their own dialogue domain-specific language on the kind of dialogue system creation.
It doesn't have this further down. They have a very simple console administration console, but as far as I know, they don't have this.
They actually do, but maybe this is not the open to the public. They have it shared with some
Generally, it is available and training is done, something like that. Usually, it's template-driven system that allows you to train.
Yeah, of course. So what I was trying to say that the DSL language, as far as I understand that, is not we actually want to build in our library. We want to have this framework where you could have your models adapted to it, like we have a module, any module for classification, any module for named entity recognition, and so on. So this is not about the domain-specific language. This is about models from our side, as far as I can see.
Can I ask one question, if you don't mind?
First.
In our startup, we use Dipalo for now for entity extraction.
So this is fine?
Yeah. Prior to that, I used to work with a company called Fitch Computing. They are located in Virginia in the United States. And they also offer entity extraction and entity disintegration in their application there. But there is a difference in these approaches. For entity disintegration, they use ontology of Wikipedia, and they build a knowledge graph from the image version of Wikipedia to make disintegration. So my question is, we as the customers, if you could call us this way, of Dipalo, how we could keep using Dipalo, but at the same time have an ability to make entity disintegration?
I think that this could be answered in this way. Sorry. Second. We have the output of our system, which is providing you with some entities as it thinks which are entities here. Inside the library, there is like specific format how the data is represented. You could use this format, and I think once you adopt it to the format the library of this Virginia company wants to see, you could use it for the disambiguation. If you by disambiguation you think you're trying to get, like, if we have here an area, maybe this is like not area or something else. So you could provide it with this raw output, and maybe it could
You have to.
Yeah, but not only. The kinds of integration we need is for main entities like people and organizations that are mentioned in the articles and documents. And there's a little bit different kind of tools.
Little
More
bit.
specific. For example, if you might, you mentioned you have a little document and it has the name Bill Gates, and then you have a technology document like a white paper, not a blockchain, but something more typical, and also involves the name Bill Gates. And in these two cases, we can agree that Bill Gates, in first case, is most possibly father of Bill Gates, actually. He is the owner of Kenner Gates company. And then the next case, the second case, is Bill Gates, father of Microsoft. So that's what we're talking about.
Yeah. So I think now I understand what you're saying is better. I think this is the answer could be the same. Like let's think of this. This is like here is said Bill Gates in some other world. The Bill Gates here is a named entity in both cases, as you said. But you also have the understanding of the domain. So if you're using the output of the domain classification, you could use it for better disambiguation. So you provide the disambiguate system with information from the classifier and with named entity recognition, and it's disambiguate the persons for you. I think like that.
What you imply, and correct me if I'm wrong, is you suggest us to build this kind of knowledge about a particular domain we're interested in, in order to actually make the integration work.
I think yes. So how I could how our system could disambiguate since it's never know about the actual possibility of two Bill Gates. Yeah, of course.
Some more questions? Speaking of entity recognition, there are slots and values, and am I right that we are free to add another slots and possible values? Is it configurable or not?
Of course, it is configurable. So you're actually defining which are the slots. Slots is like hardwired, but values they could be not hardwired, but used from external sources like SQL database. I think it's still in early release, but you could give it a try. So values are more about more flexible. If the entity is hardwired to the system you're training, once you train the entity, sorry, not entity slots, the slots are hardwired, they already there. The values could change at least a little. Yeah.
Can a slot have a value consisting of more than one word?
Yeah, of course, like this here. Yeah, it's not a problem. It's just this is just an example. It could be much bigger if you want it to be.
Yeah.
Some more questions? So let me ask you.
Yeah.
Can we get back to the example when we have one asking about time on checks?
Here? No. You're talking about this, yeah.
First of all, how do you update probabilities?
How do we update probabilities? This is just an example, of course. This is not how the system. The one of the ways how it's working. I would say a general way to work with that. We are reading all the history. We are providing this state tracking. Actually, every module is provided with a history. If you want it to be there, and we read the history, and we have all options here, like the result there. Another way is to do this. You could have like preliminary results which you are updating with each with each utterance there. So like that.
Yeah, I mean, like, more than ask about this because when I said observations, so the scheme, the show, obviously it's something you here want to apply something related to bias versus mark versus so on, but still, the question is how you learn all this traditional system. Because it seems that in general there are too many conditions, so always questions and conditions. So how do you address it?
I think I understand your question. We're actually what we actually released. This is our example Goal-Oriented Bot. There we have implicit this transition matrix, which is implicit inside of this recurrent neural network. We just getting the results out of there. You actually could build a system with exact transition matrix and update it if it's more fit to your needs. So since we have open source like that, we are not working with these exact metrics.
Yeah, sure. So, my next question is the one I already asked Sergey, previous speaker. So, now you obviously have uncertainty, and you just need to, the bot needs to decide if it's already not much to make, some efficiency, or if it needs to ask for. So, like in this example, you can still upload this probabilities many times, or you can stop somewhere and do something. So, do you work in the direction of developing policies for such handling, or you just post model for user and the user should find some sites where you want to stop? I mean, user and customer.
As you say, I see your question like in two parts. Like for the first part, you're asking about these questions, like you want to update or something. This is one of the options, and we just learning the policy when we actually want to ask this. So this is one part. The other part is when we actually ending the dialogue. This is a really interesting question. The ending dialogue is, I think, another option. We have this hello like intent. We actually have goodbye intent, and when we understand that user is trying to say us goodbye, we are just ending the dialogue. This is the other part as I see it. Am I answering the question?
Please tell me more about developing, like how do you decide whether that should be?
It's like when we have the dialogue where say person asking, could you I don't know, provide me with opening hours of Mariinsky Theater, and both the bot understands that the Mariinsky Theater is an organization. Opening hours is the say some slot. It needs to fill like what actually user wants to understand to get, and after that we have all the information we need in this simple case, and bot just have this request for database for these opening hours, giving it back, and after that we expect user to like ending the dialogue with dropping it, or ending with saying thank you and we're saying thank you goodbye, or something like that. I think this is the answer.
When you still have four slots, that probabilities that you have properly understand how you should.
Yeah, of course. This is. I would say this, I have no exact answer for this, because this is this should be tuned for the exact data. We have data like open data. This is dialogue state tracking challenge. Actually, interestingly, Facebook in a few days back released new dialogues conversation dataset, which is really huge. We should try that, but here we have only this data to try with it and to understand how it's working there, and the other data we have on the from Russian customers, I could not share it with you like that. Sorry.
So we're,
Okay.
so yeah, thank you very much.
Thank you.